All right. Do you guys see the whiteboard page that says exponential function? Okay. Thank you. Thank you guys. All right. Before we get started on exponential function, I have a little riddle, or actually, it's a math question. It's kind of silly question, but I hope you take time to think about it. Okay, because it basically capture the essence of what exponential function is. Exponential function, if there's anything that will be useful in your future in terms of a math applicability, exponential is one of the probably the number one on my list because I use it too. I use it in terms of figuring out the mortgage, loan, investment, how long it will take to, let's say, double the money, or how long does it take for me to pay off the debt for my mortgage. I mean, there are lots and lots of things. Or the car. If I keep driving my car for 5 more years, how much would my car be worth in about 5 years? I don't know. There are lots and lots. And those questions can be answered by exponential functions. So here's the riddle. If a genie appeared and gave you a choice, what would you choose? Would you, that choice, that there are two choices. Would you rather have a penny that doubles every day for a month, let's say 30 days? So you got 1 penny, 2 pennies, and you get to keep the end amount of the pennies after 30 days. Or you just receive $1 million right now. Which one would you choose? Would you like that doubling penny? And then you get to keep the 30 after the 30 days amount, you get to keep that. Or just $1 million. Some of you are already saying pennies. Have you guys seen this question before? There are like a lot of different variations. And math teachers love to use this type of story when they talk about exponential functions. I mean, what does your gut feeling tell you? I mean, it isn't normal to think that penny does not pay off very much. Because think about this. First day, you've got 1 penny. It's a nothing, right? Second day, that's 2 pennies. Third days, 4 pennies. Okay, third day. Fourth day, 8 cents. 16 cents. 32 cents. 64 cents. And then 8 days, that's like $1.30, 40 cents. Now, after 10 days or so, you only still have like a $2, $3 after 10 days. You're kind of getting nervous. Okay, 11th day. Well, let's actually. So, second day, third day, 4, 5, 6, 7, 8, 9, 10. Now, after 10 days later, you only have $5. Okay, 11, 12, 13, 14, 15. After 15 days, you only have $160. That's a nothing compared to $1 million, isn't it? Okay, 16, 17, 18, 19. After $20, now you only have $5,000. Now you only have 10 days left, right? But you only still have a $5,000. Now you're really regretting, right? I should have taken $1 million. But wait, okay? All right, so now it's $20. You only have 10 days left. 21, 22, 23, 24, 25. Now, after 25 days later, now you have $167,000. And you're thinking, wait a second, wow, right? Now you only have 5 more days left. Okay, 26 days. That's a 300,000. 27. Now you've got 671,000. That's a $500,000. Now 20, well, what's next? 27. Now you're over $1 million. Now 28. Now 2 million, 29, or did I say 29? Now you've got $5 million. Let's see. Yeah, $5 million. Now it just shoots up really quickly. Now you've got 5 millions in 30 days, 10 millions. So you end up with like a $10 million. This is the power of exponential function, most powerful function that you can think of in terms of finance. It can work for you if you are doubling part, or if you are paying, let's say, interest, and that works against you, right? And anyway, again, exponential function is one of the most powerful applicable function mathematics that you can take away. And I hope you remember this. Now, I want you to write this down, this part. Exponential function has a form y equals a times b to the x power. Okay, and I want you to write that down. A represents initial value, and we will talk about this. Okay. It's your starting number. Okay. And B is what's called a multiplier. Okay. The rate of increase, or maybe rate of decrease. Okay. And from tomorrow, we will be talking about exponential increasing pattern and decreasing pattern. And that's pretty much the goal for this week before the spring break to talk about. Okay. It's called exponential growth and exponential decay. I think many of you might have already talked about this in your Algebra 1 class, but we'll talk about this again, okay? And then after you come back, we will talk about finance by using exponential function. And that will be pretty much it for this unit and for this semester, okay? But anyway, so I hope you wrote this down. If so, you can actually figure this one out of this Gini, the example that we just talked about. The initial value for this example, initial value is a penny. So it is 0. I'll just do that with a dollar. It's a $0.01, okay? And then the multiplier is you double. So it's 2. And then you're going to, the time is 30 days or 30 times you double. Okay? So it's a 30th power. And if you do that, does anybody have a calculator? See that? Let's see how much you end up having. Boom, right? That's $10 million. Is that correct? Yeah. You end up $10 million, 700, almost $11 million. You have the doubling penny for 30 days. That's incredible. Yeah. And the growth is very, very slow at the beginning. 1 penny, 2 penny, 4, 8 penny, 16 pennies, 32 pennies, 64 pennies. That's nothing, right? And that's a year. After 5 days later, 10 days later, you end up with only $5. And after that, it gradually start to shoot up, and then boom, it takes off. So just to indicate the shape of the exponential function, let's graph a couple of things. Okay, I would like you to. There are a couple of variations of exponential function. And first of all, this is the most simple exponential function that you can have. Okay. And then we will graph that first and see what it looks like. Okay. But let's take a look. Let's do 2 to the. Let's fill out the table and then graph it. So 2 to the negative third power. Now we will be talking about negative exponent later on. Maybe we should do that first, but can somebody figure out what it is? What's in 2 to the negative third power? Does anybody have that? Okay, let's everybody take out your calculator. Just use your cell phone. What does a 2 to the negative third power say? You think it will give you a negative number? 2 to the negative third power is 0.125. Okay. 2 to the negative second power is 0.25. 2 to the negative first power is 0.5. Now, how about 2 to the 0th power? Does anybody know what 2 to the 0th power is? What do you get? Very good. And we will talk about this later on. The negative exponent, zero exponent, and so on. But for now, 2 to the 0th power is actually not 0, but it's 1. And then now you know 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and so on. So this is just a rough sketch, but when x is negative 3, y is 0.125. It's very tiny. When x is it's 0.125. When x is negative 2, it's 0.25. It's still right there, very small. When x is negative 1, now it's a half. And then when x is a 0, it's 1. When x is 1, it's 2. When x is 2, it is 4. When x is 3, it's 8. See that? Now, the one important thing here that I want you to remember, if the exponential function goes to the left, do you think the line will ever cross over the x-axis? Do you think the line will go below x-axis? The answer is, for example, the answer is actually no. The line, as you go to the left, the line will get closer and closer to the x-axis, but it will never get to it. It's kind of hard to understand. How can it be? If you are getting closer and closer, wouldn't you eventually reach to that point, get to the x-axis, if you're getting closer and closer? But it doesn't. It's kind of like this. It's when x is -1, it's a half, right? When x is -2, it's half of a half, which is 0.25. And then when x is -3, it's half of a 0.25, which is 0.125. And then for when x is -4, it's going to be half of a 0.125. And so it gets half, and then half, and then half. Mathematically speaking, there is always a half of a half, and then a half of that half, and then a half of that half. You can keep doing that forever, indefinitely in mathematics. Wouldn't you think that, well, isn't it basically becomes 0? Well, yes and no. Yes, it's half of a half. It's still something, right? And then half of that half, it is still that something. And then half of that half, it is still that something. It's kind of like this. You've got loaf of bread and you chop it in half. Then remove that. And then you chop it in half. Now you've got that this much. And then you slice them in half. And now you've got this much. And then you slice that. Now, physically, it's impossible to do that forever, but mathematically speaking, there's always the half of the half and then a half of the half. So the line gets closer and closer and closer to the x-axis, but it will never get to it. This bottom ceiling, a bottom floor, where exponential function never get to it, this type of a line is called asymptote. I think there's E at the end, asymptote. It's a funny word. I don't know what the origin of the word is. Asymptote. Some crazy mathematicians named it probably. So, okay, there are, so I want you to remember the name. We won't deal with asymptote very much in this class, but it will come up in your future math classes. Okay. Asymptote is a line, it's sort of like an invisible wall where line will get closer and closer, but it will never cross over. That invisible wall is called asymptote. Should we write that? Invisible wall. And that's what asymptote is. Okay. Now, let's just, today I will not be having any assignment, but I want you to remember the general shape of each one, A, B, C, and D. And then that will be it for N, E. There's one more, 5 of them. And then that will be it. Okay, no assignment, but I would like you to take good notes of this. Okay. Next one, B. What does that look like? Does it, anybody have any graphing calculator with you? We'll take a little bit of a time, maybe tomorrow. You can actually download a free graphing calculator on your cell phone. Did you guys know that? Whether it's Android or Apple iPhone, you can download it for free. I don't know how. I mean, they're on the store app, so it must be legal. And people are providing that. You don't have to buy this. You, if you're going to college, universities planning on that, you might buy this as well, but you don't have to for now in this class. Okay. Now, if I graph -2 to the x power, see this? So if I press graph button, which is right here, you can type in the equation and then press graph button. Graph. Now, what did that negative sign do to the original, the graph that we just went over? It reflected on x-axis. It flipped. So that's the general shape. Again, line gets closer and closer to x-axis. Okay. Next, what do you think that C, let's talk about C. Why would that negative sign in exponent, what do you think that will do? Let's take a look. So I just typed in 2 to the negative x power. And I want to graph that. Ready? 1, 2, 3. Now, what does that negative exponent do? Instead of going up to the right, you have going up to the left. And as you go to the right, the line gets closer and closer to x-axis. What if you put the both negative sign? Then basically you're going to flip that. Okay. So it will be, how does it go? Like that. Let's check. So here's the equation. And here's the graph. Hang on a second, Jason. I'll be right back. Oh, 久しぶりだね、考えたくなった。時間かかるよ。All right, sorry guys. Okay, the last one, the shape that I want you to look at, recognize is, well, what would, if you put the constant or just a number at the end, what do you think it would do? Again, it will. Now, this y equals 2 to the x power, we've already explored that. This is which is this one, a. It will basically lift everything up 3 spaces up. So here we've got, instead of this x-axis being the asymptote, now the asymptote will be right here. And then the line will go like that. And this one will be the new asymptote. There's the silent P there. Okay. So just, it's not always increasing. There are some decreasing patterns and so on. And we will be exploring that in terms of exponential growth and exponential decay problem. The things that are growing, for example, let's say, I don't know, like the population of Salem is growing about 2%, or maybe a little less than that. 10, 20 years ago, when I moved to Salem, they were saying that they are growing 2% a year, right? So with that information, let's say you've got, I don't know how many people we have in Salem, but let's say there are 100 people in the town. If you're growing 2%, how many people will there be after 5 years, 10 years? That's an exponential growth pattern. Right? And you can predict that by using exponential growth, the equation, exponential function. The type of a question that will be decreasing will be something like this, the value of your car. Okay? 99.9% of the car that you will lose the value as you drive it. Okay? Unless they are vintage or nice car, sports car, whatever, right? Otherwise, it will just keep going down. For example, let's say Mr. Takara buys a Honda. Actually, I recently bought a Honda Fit. It's a small Honda car recently for about $5,000. Okay, so if Mr. Takara keeps driving for, let's say the car loses 8% of the value, how much will the car be worth after 5 years later? So right now it's $5,000. But 5 years later, how much will the car be worth if you lose 8% of the value every year? Again, exponential function has the answer to that question. So we will be working on exponential growth, exponential decay problem for the rest of the week. And then I think that would be it before the spring break. Again, the next week will be spring break, which is kind of nice, right? Um, and then after that, we are back from a spring break. We only have 2 weeks left for this quarter. And that will be it. That will be the equivalent to semester. Okay. So we only have a very limited time left. So please keep that in mind. Okay. So this is all I have. No assignment again today. But please make sure you have this in your notes. And then I will get started, pick up from tomorrow. Okay. So you guys have a great day. And see you guys tomorrow. All right. Take care, guys. Have a great day. Don't go back to bed. Keep going. All right. Hey, Hope. I know you. I just saw you come in. I just finished the class. Today was more of an introductory lesson. I did not give any assignment today, but this is the notes. Maybe you can just take a picture of that. And I will be uploading the video today. But